What if I told you there is a planet in our solar system that no human eye has ever seen, a frozen giant, at least twice the size of Earth, 6 times heavier, hiding in the darkness where sunlight takes 3 days to arrive? It orbits so far from the Sun that 1 year on this world equals 15,000 years on Earth. The last time it completed a single orbit, mammoths still walked our planet, and humans were painting on cave walls. For over a century, scientists have chased its shadow through mathematics and gravitational whispers. They have watched distant ice worlds move in impossible patterns, pulled by something massive that refuses to show itself. In 2016, astronomers calculated the odds. There is a 99.6% chance this planet exists. Not a theory, not a guess, a near certainty. And yet, we cannot find it. It hides at the very edge of everything we know, tilted 16 degrees away from every other planet, orbiting in defiance, waiting in silence. The solar system you learned about in school is incomplete. There is something else out there, something ancient, something enormous, something that has been keeping secrets for 4 billion years. Prepare for a journey through cosmic mystery beyond comprehension. We begin. Close your eyes for a moment and picture our solar system. You probably see the Sun at the center, burning bright and gold. Around it spin 8 planets in neat circles: Mercury, Venus, Earth, Mars. Then the gas giants, Jupiter and Saturn with their rings and storms. And finally, the ice giants, Uranus and Neptune, cold and blue, marking what we think of as the outer edge. This is the solar system you learned about in school. This is the map we have carried in our minds since childhood. But what if I told you that this map is incomplete? What if, beyond everything we can see, there hides a world so distant and so dark that no human eye has ever witnessed it? Welcome to the mystery of Planet 9. Somewhere out there, far beyond the familiar paths of Neptune and Pluto, a massive object may be circling our Sun in total silence. Scientists believe this hidden world is at least twice the size of Earth. Some calculations suggest it could be even larger. And when it comes to weight, this planet might be 4, 5, or even 6 times heavier than the world beneath your feet right now. Try to imagine that for a moment. A planet bigger and heavier than Earth, made of ice and rock, drifting through the coldest reaches of space. It does not glow. It does not shine. It simply exists in darkness, so far from the Sun that our star would appear as nothing more than a bright dot in its sky, barely different from the other stars scattered across the heavens. How far away are we talking about? Let us use a simple measure. The distance from Earth to the Sun is what astronomers call 1 astronomical unit. It takes sunlight about 8 minutes to travel that distance. Neptune, the most distant known planet, orbits at about 30 astronomical units from the Sun. That already seems impossibly far. But Planet 9, this hidden giant, may orbit at distances reaching 500 astronomical units, 500 times the distance from Earth to the Sun. At that range, sunlight would take nearly 3 days to arrive, and when it does arrive, it brings almost no warmth at all. The surface of this world would be frozen beyond anything we can truly feel. Temperatures would drop to hundreds of degrees below zero. Any gas would have long since frozen solid. Any water would be harder than steel. Now here is something even stranger. Every planet in our solar system orbits the Sun on roughly the same flat plane. Imagine a giant disk spinning around the Sun, and all 8 planets ride along that disk like marbles rolling on a table. But Planet 9 does not follow this rule. Scientists believe its orbit is tilted about 16 degrees away from the rest. It moves at an angle, cutting across the paths of other worlds like a rebel, refusing to follow the crowd. Why would a planet orbit at such an odd angle? This question has puzzled astronomers for years. Some believe Planet 9 was not born in this tilted position. Something must have pushed it there. Perhaps a close encounter with another giant planet billions of years ago. Perhaps a gravitational tug from a passing star. The truth remains hidden, locked away in the darkness where this world makes its slow journey around the Sun. And when I say slow, I mean slow beyond human understanding. One orbit around the Sun, what we call a year, takes Earth roughly 365 days. Neptune, being so much farther out, takes about 165 Earth years to complete one orbit. But Planet 9 exists so far from the Sun that its orbital period stretches into the thousands of years. Some estimates suggest It could take 10,000 years to go around once. Others push that number even higher, up to 15,000 years. Think about what that means. The last time Planet 9 was in the same position it occupies tonight, human beings were still painting on cave walls. Mammoths walked the earth. The Ice Age had not yet ended. Entire civilizations have risen and fallen. Empires have been built and destroyed. And still, this planet has not completed a single trip around the sun. We have been fooled, you see. We look up at the night sky and we feel that we understand our cosmic neighborhood. We have sent robots to Mars. We have photographed the rings of Saturn. We have even sent a spacecraft past Pluto into the void beyond. But the truth is humbling. We have only scratched the surface of our own solar system. The outer reaches remain wild and unexplored, full of objects we have never seen and forces we do not fully understand. There is a strange comfort in this mystery. We live in an age where it sometimes feels like everything has been discovered, mapped, and explained. But here, at the edge of our own backyard, lies proof that the universe still holds secrets. A planet hides in the dark. It has been hiding for billions of years, and whether we find it tomorrow or 100 years from now, its presence reminds us that wonder is not dead. Some scientists remain skeptical. They argue that Planet 9 might not exist at all. Perhaps the strange behaviors we observe in the outer solar system have other explanations. Perhaps our understanding of gravity needs updating. Perhaps we are seeing patterns where there are none. But others are certain. The mathematics, they say, point clearly toward a hidden world. The evidence grows stronger with each new discovery. And so, the hunt continues, night after night, telescope after telescope, as humanity searches for a ghost it has never seen, but somehow knows is there. The journey to find this ghost has been long. It stretches back more than 2 centuries, to a time when a man with a homemade telescope accidentally changed everything we knew about the heavens. The year is 1781. In a quiet garden in the town of Bath, England, a man stands alone under the stars. His name is William Herschel, and by profession, he is not a scientist at all. He is a musician. He plays the oboe and the organ. He composes symphonies and teaches music lessons to make his living. But at night, when his work is done, Herschel turns his attention to the sky. He has built his own telescope, not purchased from a shop or borrowed from a university, but crafted with his own hands in his own home. The mirrors are polished by his sister Caroline, who shares his passion for the heavens. Together, they spend countless hours peering into the darkness, mapping the positions of stars, searching for anything unusual drifting through the cosmic ocean. On the night of March 13th, Herschel notices something strange. A small point of light sits among the stars in the constellation Gemini. But this point is different. It does not twinkle the way stars do. It appears slightly fuzzy, slightly soft around the edges. And over the following nights, Herschel watches it move against the background of fixed stars. His first thought is that he has found a comet. Comets were exciting discoveries in those days, and finding one would bring honor and recognition. Herschel reports his observation to the scientific community, describing a new comet in the outer reaches of the solar system. But something does not fit. Comets usually have tails. They grow brighter as they approach the sun, then fade as they drift away. This object does neither. It simply moves in a slow, steady path, taking its time as though it has nowhere important to be. Months of observation reveal the truth. This is no comet. William Herschel, the musician from Bath, has discovered a new planet. Try to understand how shocking this was. For thousands of years, humanity believed there were only 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. These were the wandering stars known to ancient civilizations. They appeared in myths and religions. They were woven into the fabric of human culture. And then, in a single night, a man with a homemade telescope added a 7th world to the list. The planet was eventually named Uranus, after the ancient Greek god of the sky. It sits about 19 times farther from the sun than Earth does. It takes 84 years to complete one orbit, and it is huge, about 4 times wider than our planet, and more than 14 times heavier. Here is something strange that we should pause to consider. Herschel was not actually the first person to see Uranus. The planet had appeared on star charts for decades before his discovery. Other astronomers had looked right at it and written down its position, but they never realized what they were seeing. Uranus moves so slowly and shines faintly that everyone assumed it was just another distant star. They saw it, but they did not see it. Their eyes captured the light, but their minds did not understand the meaning. This tells us something important about discovery. Sometimes the universe shows us its secrets, but we are not ready to receive them. We need not only eyes, but also the right questions. Herschel succeeded not because he had the best equipment or the greatest training. He succeeded because he was curious. He watched carefully. He noticed when something did not belong. Now, Herschel's discovery was wonderful, but it also created a problem. He found Uranus by accident. He was looking for comets and stumbled upon a planet instead. This is not exactly a method you can repeat. You cannot build a scientific program around hoping to get lucky. There had to be a better way. And this is where the story takes a fascinating turn. Once astronomers knew Uranus existed, they began tracking its orbit very carefully. They wanted to predict exactly where it would be in the sky on any given night. Using the laws of gravity discovered by Isaac Newton a century earlier, they calculated the path this new planet should follow around the Sun. But Uranus refused to cooperate. Year after year, the planet drifted slightly away from its predicted position. Sometimes it moved faster than expected. Sometimes it moved slower. The differences were small, but they were real, and they could not be explained by any known force. Some scientists wondered if Newton's laws were wrong. Perhaps gravity worked differently at great distances from the Sun. Perhaps the rules that governed falling apples and orbiting moons did not apply in the cold outer reaches of the solar system. This was a genuine scientific debate, and for a time, no one knew the answer. But others had a different idea. What if Uranus was not alone out there? What if another planet, even farther from the Sun, was pulling on Uranus with its gravity? This invisible neighbor would explain the strange wobbles. It would mean that Newton's laws were still correct, and it would mean that mathematics could be used to find new worlds. Think about how bold this idea was. These scientists were suggesting that you could discover a planet without ever seeing it. You could study the motion of one world and deduce the existence of another. The telescope would no longer be the only tool for exploration. Mathematics itself would become a kind of lens, allowing humanity to peer into the darkness and find hidden objects. This idea would soon be tested. Two astronomers, working independently on opposite sides of the English Channel, would race to calculate the position of the unseen planet. Their work would lead to one of the greatest triumphs in the history of science, and it would prove forever that when planets misbehave, the universe is trying to tell us something. The wobbles of Uranus were not a mistake. They were a message, and humanity was finally learning to read it. Imagine you are walking through a dark forest at night. You cannot see what lies ahead, but you can hear the leaves rustling. You can feel the wind shifting direction. Something is moving out there among the trees, and even though your eyes show you nothing, your other senses tell you that you are not alone. This is exactly the situation astronomers found themselves in during the early 1800s. Uranus was misbehaving. The planet refused to follow its predicted path, speeding up at certain points and slowing down at others. Something was pulling on it from the darkness beyond. The question was simple but profound. What invisible force was tugging at this distant world? Scientists have a word for this kind of strange behavior. They call it perturbation. It is a beautiful term that describes a beautiful idea. Objects in space do not suddenly change their motion for no reason. Every wobble, every drift, every unexpected shift in speed must have a cause. If a planet moves in a way that does not match our predictions, then something must be perturbing it. Some external force is reaching across the void and gently pulling on that world. The perturbations of Uranus were small. If you were riding on the planet's surface, you would never notice them. But to the careful eyes of astronomers tracking its position year after year, these tiny deviations were impossible to ignore. They were clues written in the language of gravity, waiting for someone clever enough to decode them. Two men took up this challenge. They worked at the same time but in different countries, unaware of each other's efforts. One was a French mathematician named Urbain Le Verrier. The other was an English astronomer named John Couch Adams. Both men asked the same question. If an unseen planet is pulling on Uranus, where exactly must that planet be located? This was not a simple problem. It required deep knowledge of orbital mechanics, the science of how objects move under the influence of gravity. It required countless hours of calculation, done entirely by hand with pen and paper. There were no computers in those days. Every equation, every number, every step had to be worked out slowly and carefully by a human mind. Both Le Verrier and Adams arrived at similar conclusions. They predicted that an unknown planet must exist far beyond the orbit of Uranus. They calculated its mass. They estimated its distance from the Sun. And most importantly, they identified the region of sky where this hidden world should be found. Now comes the dramatic moment in our story. In September of 1846, Leverrier sent a letter to a German astronomer named Johann Galle at the Berlin Observatory. The letter contained coordinates, a specific patch of sky where Leverrier believed the new planet would appear. Galle received the letter on September 23rd. That very night, he pointed his telescope toward the predicted location. Within just a few hours of searching, Galle found it. A small blue dot sat exactly where the mathematics said it should be. Neptune, the 8th planet from the Sun, had been discovered, not by accident, like Uranus, not by luck or random searching, but by the pure power of human thought. Mathematics had reached across billions of kilometers of empty space and plucked a new world from the darkness. This was a moment that changed science forever. It proved that we could find objects we had never seen by studying the effects of their gravity on objects we already knew. The telescope was no longer the only tool of discovery. The human mind, armed with equations and logic, could explore the universe in ways that eyes alone could never achieve. Neptune is a magnificent world. It orbits about 30 times farther from the Sun than Earth does. It takes 165 years to complete a single journey around our star. It is an ice giant, wrapped in blue clouds of methane that give it a beautiful, ghostly color. Winds on Neptune blow faster than anywhere else in the solar system, reaching speeds of over 2,000 kilometers per hour. It is a place of extreme cold and extreme violence, a world where storms larger than Earth rage for years without end. But here is something curious that we should consider. The discovery of Neptune was celebrated as a triumph of Newtonian physics. It seemed to prove that gravity worked exactly as Newton had described, even at vast distances from the Sun. Yet some scientists today wonder if we were too quick to celebrate. The calculations that led to Neptune's discovery contained some errors. Leverrier and Adams made assumptions that we now know were not entirely correct. By luck, these errors happened to cancel each other out, leading to the right answer for partly wrong reasons. Does this diminish the achievement? Not really. The planet was found exactly where the mathematics pointed, but it does remind us that science is messy. Discovery is not always a straight line from question to answer. Sometimes we stumble toward truth through a fog of incomplete knowledge, and we arrive at the correct destination without fully understanding the path we took. After Neptune was found, something interesting happened. Astronomers began looking for more wobbles, more perturbations, more gravitational fingerprints hidden in the motions of known worlds. And they thought they found one. Neptune itself seemed to have a slight wobble in its orbit, as though yet another unseen planet was pulling on it from even greater distances. The hunt was on again. If mathematics could find Neptune, perhaps it could find another world beyond. Perhaps the solar system was larger than anyone had imagined. Perhaps there were planets waiting in the darkness that would make even Neptune seem close by comparison. This search would lead to the discovery of a small, icy world in 1930. It would be named after the god of the underworld, and for 76 years, it would be called the 9th planet. But as we shall soon see, this frozen little world was hiding a secret. It was never the giant planet astronomers were looking for. It was something else entirely, and the real Planet 9 was still out there, waiting in the cold silence beyond. The year is 1930. The place is Lowell Observatory in Flagstaff, Arizona. A young astronomer named Clyde Tombaugh sits in a cold dome, night after night, staring at photographic plates covered with thousands of tiny dots. Each dot is a star. Each plate captures a small piece of the sky. And somewhere among those countless points of light, Tombaugh is searching for something that moves. His method is simple but exhausting. He takes 2 photographs of the same region of sky, separated by several days. Then he places these photographs into a device called a blink comparator. This machine rapidly switches between the 2 images, creating a flickering effect. Stars stay in the same position, so they appear steady. But if anything has moved between the 2 photographs, it will seem to jump back and forth as the images blink. Hour after hour, day after day, Tombaugh examines these plates. Most of the time, he finds nothing. Occasionally, he spots an asteroid drifting through the inner solar system, but he is looking for something else, something farther out, something beyond Neptune. Then, on February 18th, 1930, he sees it. A faint dot shifts position, between two photographs taken in January. It is small, it is distant, and it is moving exactly where astronomers predicted a ninth planet should be found. The news spreads quickly. Scientists around the world celebrate. The solar system has 9 planets now. This new world is named Pluto, after the Roman god who ruled the underworld. It seems like the perfect name for an object living in such cold darkness at the edge of the solar system. But there is a problem that would not become clear for many years. And to understand this problem, we need to talk about something called observational bias. Observational bias is one of the trickiest traps in science. It happens when you go looking for a specific thing and then convince yourself you have found it, even when the evidence does not quite match what you expected. Your desire to find an answer shapes the way you interpret what you see. Here is what happened with Pluto. Astronomers went looking for a massive planet beyond Neptune, something large enough to pull on Neptune with its gravity, something capable of causing the wobbles they had observed in Neptune's orbit. They predicted where this planet should be. Then Tombaugh found an object in roughly that predicted location. Therefore, they concluded, this must be the planet they were looking for. The search was over. Mystery solved. But they were wrong. Pluto appeared bright through the telescope. When light hits something reflective, it bounces back toward our eyes, making that object seem larger and more substantial than it really is. Pluto's surface is covered in frozen nitrogen and methane ice. These materials are highly reflective. They shine beautifully when touched by sunlight. So through a powerful telescope, Pluto looked big and important. But appearances deceive. In reality, Pluto is tiny. It measures only about 2,300 kilometers across. That is smaller than Earth's moon. It is smaller than 7 other moons in our solar system. Its mass is so small that if you could somehow place Pluto on a cosmic scale, you would need more than 450 Plutos to equal the weight of Earth. This creates an obvious problem. A world this small and light could never pull on Neptune hard enough to cause noticeable perturbations. The wobbles that scientists had observed in Neptune's orbit could not possibly be caused by Pluto. Something else was going on. It took decades for the truth to emerge. As telescopes improved and measurements became more precise, astronomers realized they had made an error. Neptune did not actually have a wobble. After all, the strange behavior they had seen in the 1800s and early 1900s was simply a mistake in measurement. The instruments of that era were not accurate enough. The calculations contained small errors that added up over time. When astronomers finally corrected these mistakes, Neptune's orbit looked perfectly normal. There was no perturbation. There was nothing pulling on it from beyond. This means that Pluto was never the planet they were searching for. The discovery was real, but the reasoning behind it was flawed. Tombaugh had found something genuinely interesting and important, but he had not found the massive 9th planet that orbital mechanics seemed to predict. Now, here is where the story becomes more complex. For most of the 20th century, Pluto was still considered a full planet. Children learned in school that the solar system had 9 worlds. Textbooks listed them in order. Mnemonics were invented to help students remember their names. My very educated mother just served us 9 pizzas. Pluto held its place at the end of that sentence for 76 years. But science does not stay still. As technology advanced, astronomers began discovering more objects out near Pluto's orbit. Some were almost as large as Pluto itself. One called Eris turned out to be even heavier. A question arose that could not be ignored. If Pluto is a planet, then are all these other icy objects planets too? Would we need to memorize 50 planets? 100? In 2006, the International Astronomical Union made a controversial decision. They created a new definition of what counts as a planet. According to this definition, a planet must do 3 things. It must orbit the Sun. It must be large enough that gravity has pulled it into a round shape, and it must have cleared other objects out of its orbital path. Pluto passes the first 2 tests, but fails the third. Its neighborhood is crowded with thousands of other icy bodies. So officially, Pluto was reclassified as a dwarf planet. It still exists. It is still fascinating, but it no longer sits at the table with the 8 major worlds. Some people were upset by this decision. They felt an emotional attachment to Pluto. Others argued that the definition was arbitrary. These debates continue even today, reminding us that science is not just about cold facts. It is also about human beings deciding how to organize and label the universe. But here is what matters for our story. The demotion of Pluto did not end the search for a 9th planet. If anything, it renewed the hunt with fresh energy. Because even though Neptune's wobble turned out to be an illusion, strange things were still happening in the outer solar system. Objects were moving in ways that did not make sense. And the more astronomers looked into the distant darkness, the more mysteries they found waiting. Beyond Neptune, beyond Pluto, beyond the edge of what most people imagine when they picture our solar system, there exists a vast wilderness of ice and rock. This region is called the Kuiper Belt, named after the Dutch astronomer Gerard Kuiper, who predicted its existence in 1951. It is one of the coldest, darkest, most mysterious places in our cosmic neighborhood. Imagine an enormous ring of debris circling the sun at a distance so great that sunlight arrives weak and pale, barely strong enough to cast shadows. The Kuiper Belt begins roughly where Neptune orbits and extends outward for billions of kilometers. It is shaped like a thick disk filled with leftover material from the birth of the solar system. These are the scraps that never came together to form planets. They are the forgotten remnants of creation, frozen in time and space for more than 4 billion years. Pluto lives here. It is not alone, far from it. In fact, Pluto is just one citizen in a city of billions. Astronomers estimate there are thousands of objects in the Kuiper Belt that are roughly the same size as Pluto. We have identified only a handful of them so far. Most remain undiscovered, too distant and too dark for our telescopes to see clearly. And then there are the smaller objects. Current estimates suggest there are at least 100 billion, yes, billion, objects in the Kuiper Belt that measure 1 kilometer across or larger. 100 billion chunks of ice and rock, each one drifting silently through the void. Some are round, some are jagged and irregular. Some travel alone, others orbit in pairs, locked together by gravity in a slow cosmic dance. To give you a sense of scale, imagine trying to count to 100 billion. If you counted one number every second without stopping, it would take you more than 3,000 years to finish. That is how many objects are floating out there in the Kuiper Belt, and we have seen only a tiny fraction of them. Now, you might wonder why these objects exist in the first place. Why did they never come together to form a planet? The answer is density. In the inner solar system, where Earth and Mars formed, there was plenty of material packed into a relatively small space. Dust and rock collided frequently. Over millions of years, these collisions built up larger and larger bodies until planets emerged. But the Kuiper Belt is different. Out here, space is vast, and material is spread thin. Objects drift so far apart that they rarely collide. There simply was not enough density to build a full-sized planet. Instead, we are left with this enormous field of fragments, a cosmic graveyard of worlds that were never born. For many years, scientists assumed the Kuiper Belt was a boring place, just a bunch of random ice chunks tumbling through space with no particular order or pattern. But as technology improved and astronomers discovered more of these distant objects, something strange began to emerge. Some Kuiper Belt objects were not moving randomly. They seemed to be organized, grouped together, aligned in ways that defied simple explanation. In particular, astronomers noticed a cluster of objects on the outer edge of the Kuiper Belt, moving in long, stretched-out orbits. These orbits were all tilted at similar angles. They all pointed in roughly the same direction. It looked as though some invisible hand had reached into the chaos and arranged these objects into a pattern. This was not what you would expect from random chance. If you throw a handful of stones into a pond, they land in different places, pointing different directions. They spread out naturally. But if you come back later and find all the stones lined up in neat rows, you know something must have moved them. Some force acted on those stones after they landed. The same logic applies to the Kuiper Belt. These objects should be scattered randomly after billions of years of drifting through space, but they are not scattered. They are aligned, and alignment means influence. Scientists found other strange behaviors as well. Some objects were orbiting over and under the sun instead of around the middle like normal planets do. Imagine a Ferris wheel spinning horizontally. Most planets move like seats on that wheel, going around the rim, but some Kuiper Belt objects move more like a roller coaster, going up and over the top, then down and under the bottom. Even stranger, a few objects were traveling in the opposite direction compared to everything else in the solar system. Almost every planet, moon, and asteroid orbits the sun in the same direction, the direction the sun itself is spinning. This makes sense because everything formed from the same rotating disk of gas and dust. But these rebellious Kuiper Belt objects ignored the rule. They travel backward, against the cosmic traffic. None of this should be happening naturally. These behaviors suggest that something massive is out there, something with powerful gravity that has been shaping and guiding these objects for billions of years. The Kuiper Belt is not random chaos. It is a carefully sculpted structure, and the sculptor remains hidden. Think of it this way. If you walk into a room and see papers scattered across the floor, you might assume the wind blew them around randomly. But if you see those same papers arranged in neat piles, sorted by size and color, you know someone was in that room, organizing them. The papers themselves tell you a story about an unseen presence. The Kuiper Belt objects are telling us a story too. They are whispering about something enormous lurking in the darkness beyond. Something that pulls and pushes and shepherds these frozen wanderers into patterns we are only beginning to understand. And in 2016, 2 astronomers decided to listen very carefully to what those whispers were saying. At the California Institute of Technology in Pasadena, 2 astronomers were becoming obsessed with a puzzle. Their names are Mike Brown and Konstantin Batygin. They spent their days studying the most distant objects in the solar system, tracking tiny points of light that took hours of exposure time just to photograph. Most scientists would find this work tedious, but Brown and Batygin saw something that others had missed. They saw a message hidden in the orbits. Mike Brown has an interesting history with planets. Years earlier, he discovered Eris, the icy world beyond Pluto that turned out to be heavier than Pluto itself. That discovery helped trigger Pluto's demotion from planet to dwarf planet in 2006. Brown sometimes jokes that he killed Pluto, but he does not feel guilty. He believes science must follow the truth, even when the truth is uncomfortable or unpopular. Konstantin Batygin is a theoretical astrophysicist. While Brown searches the sky with telescopes, Batygin searches with mathematics. He builds models of the solar system inside computers, running simulations that show how gravity shapes the orbits of distant worlds. Together, these 2 men combine observation and theory into a powerful tool for discovery. In 2016, they published a paper that sent waves through the astronomical community. The paper presented evidence for a massive, undiscovered planet hiding in the outer solar system. Not a dwarf planet like Pluto, not a large asteroid or comet, but a real planet, a giant world that could reclaim the title of 9th planet and restore the solar system to the neat list of 9 that many people still remember. What evidence did they find? It started with 6 Kuiper Belt objects located on the extreme outer edge of that distant region. These objects all had extremely long, stretched out orbits. Each one would swing close to the Sun, relatively speaking, and then travel outward for billions of kilometers before slowly turning around and heading back. This kind of orbit is not unusual by itself. Many comets follow similar paths, but here is what caught Brown and Batygin's attention. All 6 of these objects had their closest approach to the Sun pointing in the same direction. Imagine 6 runners on an oval track. They are spread out at different positions, but when each runner reaches a certain point on the track, they all turn left at exactly the same spot. That is what these Kuiper Belt objects were doing. The odds of this happening by random chance are extremely low. If these objects had formed naturally and drifted through space without any outside influence, they should be oriented in random directions. But they were not random. They were clustered, aligned, organized. Brown and Batygin considered various explanations. Perhaps they were seeing a selection bias. Maybe the way astronomers search for distant objects makes them more likely to find ones with certain types of orbits. But after careful analysis, they ruled this out. The pattern was real, not an artifact of observation. So they asked the question that scientists have been asking for 200 years. What unseen force could be creating this pattern? And their answer was the same answer that led to the discovery of Neptune. There must be a large planet out there, pulling on these distant objects with its gravity, shepherding them into alignment. But making a claim is not enough in science. You must back it up with evidence. So Batygin built a computer simulation. He created a digital model of the solar system, as it would have existed billions of years ago, back when the planets had just finished forming. Everything was raw and chaotic then. Debris filled the space between worlds. Orbits had not yet settled into their current stable patterns. Batygin ran this simulation forward in time, letting billions of years pass in the span of hours inside the computer. He watched as gravity slowly shaped the solar system into the structure we see today. But he ran the simulation twice, with one crucial difference. In the first version, the simulation included only the 8 known planets. The computer calculated how every object should move under the influence of the Sun, Jupiter, Saturn, Uranus, and Neptune. After billions of simulated years, the solar system reached its present state. But the Kuiper Belt objects did not match reality. They scattered randomly, with no special alignment or clustering. In the second version, Batygin added one more ingredient, a massive planet in the outer darkness, a world at least 5 times heavier than Earth, orbiting at hundreds of astronomical units from the Sun. He gave this planet the tilted, elongated orbit that Brown and he had predicted based on the observed clustering of Kuiper Belt objects. Then, he let the simulation run again. Billions of years passed. Gravity pulled and pushed, orbits shifted and settled. And when the simulation reached the present day, something remarkable happened. The Kuiper Belt objects lined up exactly as we see them in reality. The clustering was there. The alignments matched. The strange tilted orbits appeared naturally as a result of Planet 9's gravitational influence. This was powerful evidence. The simulation strongly suggested that Planet 9 is not just possible, but likely. After running many variations and accounting for uncertainties, Brown and Batygin calculated the probability. Their conclusion? There is a 99.6% certainty that Planet 9 exists. Let that number sink in for a moment. Not 70%, not 85%, but 99.6%. That level of confidence is rare in astronomy, especially when talking about an object no one has ever seen. It means that if you ran this experiment 1,000 times, in 996 of those cases, the best explanation for what we observe would be a hidden planet. Of course, science is not about certainty. It is about evidence and probability. Some astronomers remain skeptical. They propose alternative explanations. Perhaps there is no single large planet, but instead a disk of smaller objects whose combined gravity creates similar effects. Perhaps our understanding of gravity needs refinement at such extreme distances. These are fair questions worth investigating, but Brown and Batygin stand by their work. The mathematics is sound, the simulations are robust, and every new Kuiper Belt object discovered since 2016 seems to strengthen their case rather than weaken it. The evidence continues to accumulate, pointing toward the same conclusion. Something massive is out there, somewhere in the cold darkness, hidden but present, invisible but real. The prophecy has been made. Planet 9 exists. Now comes the hard part, actually finding it. So we have strong evidence that Planet 9 exists. We have calculated its likely size and mass. We have predicted where its gravity should be felt. But now a deeper question emerges, one that touches on the very formation of our solar system. How did such a massive planet end up so far from the Sun? This question matters because of what we learned in the previous section. The Kuiper Belt exists because there was not enough material out there to build a full planet. The density was too low. Matter was spread too thin across too much space. If you tried to gather all the ice and rock in the Kuiper Belt into a single world, you might create something the size of Earth's moon. Maybe, certainly nothing close to a planet 5 or 6 times heavier than Earth. So if Planet 9 could not have formed where it currently lives, then it must have come from somewhere else. The question is where? And the answer takes us on 2 very different journeys through cosmic history. The first possibility sounds like something from science fiction, but it is grounded in solid physics. Planet 9 might be a rogue, a wanderer, a world that was born orbiting a completely different star in a completely different solar system, then lost its home and drifted through interstellar space until our Sun captured it billions of years ago. Rogue planets are not just theoretical. Astronomers have detected them floating through the galaxy, untethered to any star. These are worlds in eternal night, planets that have known darkness for so long they have forgotten what it means to orbit a sun. They drift between the stars, alone and frozen, traveling through the void at tremendous speeds. How does a planet become a rogue? It happens during the violent early days of a solar system's formation. Imagine a young star surrounded by a disk of gas and dust. Planets are beginning to coalesce from this material, but the system is unstable. Orbits cross. Giant worlds swing close to each other, and when 2 massive planets pass too near, their gravitational interaction can be catastrophic. One planet gains energy and moves into a higher, more distant orbit. The other loses energy and either falls toward the star or, if the interaction is powerful enough, gets flung out of the solar system entirely, ejected, exiled, cast into the darkness between stars with no hope of return. These rogue planets travel through the galaxy for millions or billions of years. Most will wander forever, but occasionally one will pass close to another star. If the approach happens at just the right distance and just the right speed, the star's gravity can capture the rogue. The planet trades its lonely journey through interstellar space for a new orbit, far from its original birthplace, but at least connected to a star once again. Could this have happened to Planet 9? Could our Sun have reached out across the void 4 billion years ago and captured a wandering world? The mathematics says it is possible. The Sun's gravity extends far into space, and in the early solar system, there was more debris and gas to help slow down passing objects. A rogue planet entering this region might have lost just enough speed to become gravitationally bound to the Sun. If this is true, then Planet 9 is an immigrant, a refugee from another solar system. Its core might have formed from materials that never existed anywhere near Earth. The atoms in its rocks might have condensed from clouds around a different star, perhaps one that no longer exists. This would make Planet 9 not just distant in space, but distant in origin, a piece of someone else's cosmic neighborhood that ended up in ours by accident. But there is a second possibility, and it is equally dramatic. Planet 9 might have been born right here in our solar system, not out in the Kuiper Belt where it lives now, but much closer to the Sun, in the region between Saturn and Neptune. Picture the solar system in its infancy. Gas and dust swirl around the young Sun. Jupiter has already formed, a massive giant dominating the middle regions. Saturn is growing nearby, and farther out, 2 more large planets are beginning to take shape. We would eventually call them Uranus and Neptune, but at this point, they are just dense cores pulling in more and more material. Now imagine a 5th core forming in that same region, a world somewhere between Saturn and Neptune, gathering ice and rock and gas, starting the long process of becoming another giant planet. But the neighborhood is crowded. The gravitational dance between these growing worlds becomes unstable. Jupiter and Saturn pull on each other. Uranus and Neptune drift in their own chaotic orbits, and this 5th planet, not yet fully formed, gets caught in the gravitational crossfire. A close encounter with one of the other giants sends it flying outward. It is kicked like a stone from a slingshot, flung toward the outer edge of the solar system. But here is the crucial detail. The kick was not quite strong enough to make this world go rogue. It did not escape the Sun's gravity entirely. Instead, it ended up in a strange liminal space, trapped on the very edge of the solar system, too far to interact with the other planets anymore, too close to drift away into interstellar space, stuck in exile, a failed gas giant that never got the chance to fully grow. In either scenario, captured rogue or ejected native, Planet 9 would be an incredibly dense ball of rock, metal, and frozen material. Think of it as the core of a planet that never completed its development. No thick atmosphere of hydrogen and helium like Jupiter has. No beautiful rings like Saturn. No blue methane clouds like Neptune. Just the bare bones, the skeleton of a world. The surface would be unimaginably cold, even colder than Pluto, which already holds temperatures around negative 230 degrees Celsius. Out where Planet 9 orbits, the Sun provides almost no warmth. Any heat this world once had from its formation would have radiated away billions of years ago. What remains is a silent, frozen monument to cosmic violence and chance. We know a lot about this planet we have never seen. We know it is massive and distant and tilted. We know it influences the Kuiper Belt. We have calculated its likely orbit and estimated its composition. But all of this knowledge is built on inference and mathematics. The planet itself remains invisible, hidden, waiting. And that brings us to the final question. If Planet 9 is really out there, why haven't we found it yet? Finding Neptune was challenging, but astronomers knew exactly where to look. The mathematics pointed to a specific patch of sky. Johann Galle aimed his telescope at that location, and within hours, he found the planet. It was difficult, yes, but it was achievable with the technology of 1846. Finding Planet 9 is something else entirely. It is not like finding Neptune. It is more like searching for a single black grain of sand on a beach at midnight with only a small flashlight. Consider the obstacles. Neptune orbits about 30 times farther from the Sun than Earth does. Planet 9 may orbit 15 times farther than Neptune. That puts it at distances reaching 500 astronomical units from the Sun. At that range, sunlight is so weak that the planet would reflect almost nothing back toward Earth. It would be extraordinarily faint. Neptune is also a bright, vibrant world with an atmosphere full of blue methane gas that reflects light beautifully. Planet 9 has no such atmosphere. It is likely just a dark ball of rock and ice, absorbing most of the feeble light that reaches it. This makes it smaller in appearance and harder to detect, even if you point a telescope directly at it. And here is perhaps the biggest problem. We do not know exactly where it is. The calculations by Brown and Battigan narrow down a large region of sky where the planet should exist, but that region is still enormous. Imagine being told to find a specific person somewhere in Asia. You know they exist. You even know roughly which part of the continent they live in. But Asia is huge. You could search for years and never cross paths with the person you are looking for. Planet 9's orbit takes thousands of years to complete. It might currently be at the farthest point in that orbit, where it moves slowest and reflects the least light. Or it might be passing in front of a dense region of the Milky Way, lost among millions of background stars. We are essentially searching for a needle in a cosmic haystack, and we do not even know which haystack to search first. Yet despite these challenges, some astronomers remain skeptical that Planet 9 exists at all. Remember the concept of observational bias we discussed earlier? Brown and Battigan went looking specifically for evidence of a hidden planet. They found patterns in the Kuiper Belt. They ran simulations. They calculated probabilities. But could they be seeing what they want to see rather than what is actually there? Alternative explanations exist. One of the strangest is the possibility of a primordial black hole wandering through our solar system. These are not the massive black holes formed when giant stars collapse. Primordial black holes are theorized to have formed in the first moments after the Big Bang, when the universe was incredibly dense. Tiny pockets of matter, compressed beyond imagination, could have collapsed directly into black holes without ever becoming stars first. Such an object would be incredibly small, perhaps no larger than a grapefruit, but contain the mass of several Earths. Its gravity would be immense, powerful enough to influence Kuiper Belt objects just like a hidden planet would, and it would be completely invisible because no light could escape from it. This idea is fascinating and terrifying in equal measure, but most scientists consider it unlikely. Primordial black holes remain purely theoretical. We have no confirmed evidence they exist at all. A simpler explanation suggests that gravity itself might behave differently at such vast distances from the Sun. Every prediction we make about orbits and gravitational influence relies on laws written by Isaac Newton more than 300 years ago. Newton was brilliant, but he had never observed anything more distant than Saturn. Perhaps at extreme ranges, gravity has subtle properties we have not yet discovered. Perhaps the strange behaviors in the Kuiper Belt are simply nature showing us something new about how the universe works. These debates will continue. Scientists will argue and calculate and propose new theories. But soon, we may not need to argue anymore. Soon, we will have new eyes capable of seeing what has remained hidden for so long. In the mountains of northern Chile, under some of the clearest skies on Earth, stands the Vera Rubin Observatory. It is named after the astronomer who discovered evidence for dark matter, a woman who spent her career searching for invisible things. The name is fitting. This telescope represents the cutting edge of astronomical technology. It contains the largest and highest resolution digital camera ever built for astronomy. The camera captures images with more than 3 billion pixels, allowing it to photograph incredibly faint and distant objects. And the telescope is mounted on a motorized system that can swivel and turn with remarkable speed and precision. Here is what makes Vera Rubin truly special. Most telescopes focus on small areas of the sky, studying individual objects in great detail. But Vera Rubin takes a different approach. It scans the entire visible night sky, over and over again. Every 3 days, it completes one full scan. Then it starts again and again. The observatory began operations in the summer of 2025. Its mission will continue for at least 10 years. Over that decade, it will create something unprecedented, a time-lapse video of the entire cosmos. Every star, every galaxy, every asteroid, and every distant planet will be photographed repeatedly, allowing astronomers to watch how things move and change over time. This method transforms the search for Planet 9. Instead of looking for the planet directly, astronomers can simply watch the time-lapse and wait for something to move in the pattern predicted by Brown and Battigan. If a massive object is slowly drifting across the background stars in a long tilted orbit far beyond Neptune, the Vera Rubin Observatory will see it. Not immediately, perhaps, but within the 10-year mission, it will reveal itself, and Planet 9 will not be the only discovery. The telescope will find new comets streaking in from the outer solar system, It will spot asteroids on paths that bring them close to Earth. It may even detect interstellar objects passing through our neighborhood from other star systems. Visitors from distant suns carrying messages about worlds we can barely imagine. The universe is not done surprising us. We stand on the edge of a new era of discovery, equipped with tools our ancestors could never have dreamed of. The darkness that has hidden so many secrets is beginning to give way to light. Not all at once, not dramatically, but slowly, steadily, image by image, night by night. And perhaps one evening soon, an astronomer will notice a faint dot that has moved slightly between two photographs. They will check the data, run calculations, confirm the observation, and they will realize they are looking at a world no human has ever seen before. A giant frozen sphere at the edge of our cosmic home. Planet 9. Real. Found. No longer a ghost. Until then, we wait beneath the stars, wondering what else is out there, hidden just beyond the light.